So today we're going to move on to actually some easy stuff, and let me know if this is something you guys saw before so we can blow through it a little quickly. We're going to talk about ratios. You guys talk about those last semester at all? A little bit. What a ratio is a comparison between two numbers or two quantities. For example, we could look around the room here and compare students with hats on to students without hats on. There are 2 students with hats to 1, 2, 3, 4, 5 students without hats. Too late, you don't count. We could either write it like this as 2 over 5 as a fraction. We could write it with a colon like this, 2 to 5, or we could actually write it with the words 2 to 5. All 3 of those are valid ways of writing a ratio. I generally use the fraction notation like this because there are a lot of things you can do in that notation that you would do with a regular fraction. For example, let's say this table here. A width to length ratio, that's 18 inches wide, and at 6 feet, that's 72 inches long. Well, just like any other fraction, I can divide out the inches, and then I can reduce. Both 18 and 72 can be divided by 18. Gives me a 1 to 4 ratio. Or I could compare, it don't work in this room, I was going to compare boys to girls, but that comparison doesn't work. What's that? Let's compare my total students, males to females in my total classes. I have, we'll just make up numbers, 48 males to 20 female students. Yeah. So I can write it as a fraction like that, and it can be reduced. Both of those numbers can be divided by 4, which gives me a 12 to 5 ratio. Now here's one of the differences between a fraction and a ratio. We reduce it just like a fraction, but we would not change this into a mixed number. It would not become 2 2/5. Because remember, a ratio has to compare 2 numbers. It's 12 compared to 5. It's not 2 2/5. So that's one of the big differences between a fraction and a ratio that we have to make sure we stay with. Now you'll notice in all the examples I've done so far, I compared students to students, inches to inches, again, students to students. I compared 2 things that have the same label or the same name. If I have like 2 feet compared to 18 inches, is that truly a ratio? Not the way it's written right now, because it's feet compared to inches. To be a ratio, it has to compare 2 things with the same label. I can change that, however, into 24 inches to 18 inches. And now, of course, it'll reduce. Inches divide out, both divided by 6 to give me a 4 to 3 ratio. Again, it's not 1 1/3, it's a 4 to 3 ratio. So if ratios have to compare things with the same labels or same names, what happens if we have 2 things that are different labels? Let's say that we're going to send Colt on a road trip. He's going to drive 365 miles in 7 hours. There's no way I can convert miles into hours or hours into miles. This cannot be a ratio. That's what we call a rate. The first big difference between a ratio and a rate is just that. A rate can compare 2 things with different labels. The second big difference is a ratio, we reduce it as far as we can, like 4 to 3 or 12 to 5 or 1 to 4. A rate is almost always reduced to what we call a unit rate. In a unit rate, the denominator is 1. So we would divide this by 7 to make that 1 hour in the denominator. If we divide by 7 up here, that would give us, 52.14285714 approximately miles. You can double check me if you want to.
No, I know it's right.
Okay. So that's a unit rate. The denominator is 1. A lot of times we take out that fraction notation. Let's say we round this to 52.14. Right, like that. 52.14 miles per hour, where the fraction gets hidden in the units. And sometimes we even go a step further and we kind of hide it even further. Like, let's say your car gets 27 mpg. You don't see a fraction there at all, but it is. What's mpg stand for? Miles per gallon. So when you see 27 mpg, you need to think 27 miles per 1 gallon. Because this is the form you need it in to do any calculations with it. Rates are all around us. We just saw miles per hour, miles per gallon. Any of you that have ever had a job know this one, dollars per hour, your wage. If you get $9 per hour, that's a rate. Interest rates, stuff like that. Revolutions per minute, RPMs, that's a rate.
That's creepy.
Your phone just turned on by itself. So anyway, yeah, there's all sorts of other rates out there, like pounds per cubic foot. You know, your wood, depending on your species, it might be 63 pounds per cubic foot for your wood and stuff like that. You can figure out weights and all that good stuff. So let's switch over now from rates and let's go back to ratios again and look at ratios. We're going to expand your imagination a little bit because I'm going to draw pictures, and I suck at drawing, so you're going to have to use your imagination. Any guesses?
Sun. Or sunflower.
Come on, it's not that bad. There we go, gear ratio. A gear ratio is number of teeth in the driven gear compared to the number of teeth in the driving gear. So anyway, if we look at these, this one has 10 teeth and this one has 6. How do you know which one's driven and which one's driving? Well, right now we don't. A lot of times there's like a little arrow like this that's saying this one's powered, or we could have an indicator like this. You know, pretend that looks like a little electric motor. That's saying that one's being powered. Now, if I separate the gears, one of them's going to stop. Which one's that? The 6. That's the driven gear. It's being driven by the other gear. If we separate them, that one stops, so it's no longer driven. That's the driven gear. The one that's doing the driving is the one hooked to the motor. In this case, that's the 10. So this is a 6 to 10 or reduced to 3 to 5 gear ratio. We'd have a pulley ratio. Pulleys have no teeth, so we can't use the teeth for the ratio. When we counted the teeth on the gears, for 2 gears to mesh together, those teeth have to be exactly the same distance apart. So counting the teeth was just figuring out the size of the gear. Well, on pulleys, there are no teeth, so we can just compare the diameter or the radius or whatever. The radius, diameter, or circumference of the pulley, any of those 3 will give us the same ratio. So let's assume that the motor is hooked up right here. Pretend that looks like a little electric motor. Which one is going to go on top, the 4 or the 10?
4.
If I cut the belt, which one stops turning? The 10. That's the driven one. So 10 inches and 4 inches. Of course, the inches divide out. Both divide by 2. That's a 5 to 2 pulley ratio. Any guesses? You got it. This is a compression ratio. A compression ratio compares the expanded volume to the compressed volume. Expanded is when the piston's at the bottom of the stroke or bottom dead center, when the volume above it is at its largest, its maximum. Compressed is when the piston's at the top of the stroke or top dead center, and the volume above it is its smallest. So let's say that this is 48 cubic centimeters here, and this is 1,080 cubic centimeters here. Which one of those goes on top? Expanded implies big number, right? So 1,080 on top, 48 on bottom. Of course, the cubic centimeters cancel out. They divide out. Both of those can be reduced by, any guesses? Yeah, you can divide by 48. Gives you 22.5. No, it doesn't divide by 48. It divides by 24. Gives you a 45:2 compression ratio. This is a little high. That's even above your diesels there. For you guys, what's that? That's pretty souped up. Yeah. For you guys, some things are a little more important. Grade is one that you're into. Grade is a ratio of rise to run. Usually it's rise per 100 feet of run is a grade. Final ratio was 45:2. So if you're looking at the grade of land, that's rise per 100 feet of run. Now, most grades is usually, because of the 100 feet of run, it's usually listed as a percent, like 6%, 8%. Well, that doesn't sound really steep, does it? 6%, 6 feet of rise per 100 feet of run. Anybody ever driven on Highway 8 over by St. Croix Falls, where the hill goes down towards the St. Croix River? Pretty steep hill. Anybody know what that is? What slope that is? What grade? It's a 6%. That's only 6%. It doesn't sound like much, 6 feet and 100 feet, but that is 6%. Yeah. It sounds like a nice shallow slope, but it's, when you're on a road, that's pretty healthy slope. I think 8% is the maximum allowable for a major highway. County roads can be more than that. Yeah, I've been in some spots where that's like a 30-degree grade, 30-degree slope. Yeah. You get down in Kentucky, Tennessee, you get in some areas on, is it I-65 down there, I think it is, where they've got the runaway truck lanes.
Those are crazy. Yeah, those are the big ones. Yeah. Like this.
Makes you a little nervous.
Yeah.
And there was one spot there where I shifted into neutral and I coasted down the hill. And you have to hit the brakes every few minutes because you look down and be doing 85. But I didn't touch the gas, didn't put it in gear for like 7 or 8 miles.
My dad put the film all that. It was all easier on the brake.
Oh, sure. So it drags a little bit, engine drag. For you guys, one of the more applicable ones are slope and pitch. Have you guys talked about the difference between slope and pitch yet? This is one of those very, very commonly misused and misunderstood terms. I worked as an engineer at a truss plant for a while, and they used the terms incorrectly. It drove me nuts, but they wouldn't change. You hear of, they refer to, oh, that roof has a 612 pitch to it. It does not have a 612 pitch. It's a 612 slope. Slope is rise over run. Let's say that this is a 24-foot span, and this is 6 feet high. So 6 feet is your rise. Your run, however, is half that span. It's 12 feet. So it's a rise of 6 over 12 feet of run. That's a 612 slope. That's what it's defined to be. A 612 slope and a 612 pitch are not the same. In fact, you don't have a 612 pitch. The pitch is height over span. So on this one, the height is 6 feet, the span is 24. That is a 1/4 pitch. Why is it different? Well, slope is commonly used to refer to trusses. When you have pre-built trusses for a roof, a 612 slope allows you to find angles, heel angles and stuff like that, butt cut angles and all those things very quickly from the slope. The pitch is used when you had the old conventionally framed beam and rafter roofs. Let's say you wanted a 1/4 pitch and you have a roof that is 30-foot span. Well, what's 1/4 of 30? 7.5, right? So that's saying you just take your pitch times your span, you get 7.5 feet. That tells you that the top of your ridge beam has to be 7.5 feet above the top of your wall. So the pitch is to locate the top of your ridge beam very, very quickly when you're doing a conventionally framed roof. Somewhere along the line, the word pitch started to get confused with slope, and they started talking about 412 pitches and 612 pitches. There's no such thing. There's 412 slopes and 612 slopes. They're not pitches. If Scott starts calling him a 412 pitch, correct him. Tell him I said so.
Slap them on.
Yeah, tell him I said so. Tell him to come talk to him. It's very commonly misused in the industry.
So you want a quarter?
Yeah, it's a 1/4 pitch. Means that the height of the ridge beam above the walls is 1/4 of the span. And that's why they use it that way, because it's very quick then to calculate. You know, a 1/3 pitch, which is roughly that's an 812 slope, I believe. I'm trying to remember right. So your 1/3, yeah, it's an 812 slope. A 1/3 pitch is 1/3 of the span, then would be your height. So that'd be 10 feet from the top of the wall to the top of the ridge beam. In your book, on page 154, is exercise 4-2, 1 through 31, the odds. We're dealing with ratios.
That's creepy.
You're psychic. The spirits are calling to you. That's what I'm going to call my buddy from New Richmond. My son has a basketball game in Hammond on Saturday. So that's going to be close enough to the Richmond. I'm going to call him and see if he's got keys made, so I can pick up keys for his cabin and let the cell phone die, or just turn it off and pretend it died. One of the two. Spend the weekend in a cabin.